What is code? Mathematics code is a trick in making statement, series of numbers, or a mixture of digits. Mathematical codes can be solved only by using mathematical logical patterns. Mathematics code can also be mixed with a certain alphabets. Again, logically set is used based on exact mathematical ways. There are three common coding schemes. The first is ASCII, or stand for American Standard Code for Information Interchange. What is ASCII? It is the most common format for the text in computers and on the internet. In an ASCII file, each alphabetic, numeric, or special characters in representation with a 7-bit binary number, a string of 70% or 118, 128 possible characters are defined.
Extended Coded Decimal Interchange Code. It is a binary code for alphabetic numeric characters that IBM developed for its largest systems. Internet Business Machines is the largest computer company in the world. IBM started in 1911 as a producer of punch card tabulating machines. IBM came to dominate the new field of mainframe and mini-computers. It has 8-bit code, 4 bits for zone, 4 bits for digit. Unicode or Universal Code is the coding scheme that is New American National Standards Institute. It supports most of the world's languages and is becoming the Internet standard. It is a 16-bit coding scheme that has the capacity of representing more than 65,000 characters and symbols. It represents text, symbols, characters in multilingual environment. It uniquely represents a symbol language like China and Japanese, and mathematical and scientific symbols.
What is integer in computer? An integer in computer science is a datum of integral data type that represents some range of mathematical integers. Integers are commonly represented in a computer as a group of binary digits. The value of an item with an integral type is mathematical integer that it corresponds to. Integral types may be unsigned, means it is capable of representing non-negative integers, or signed, means it is capable of representing negative integers as well. The term byte initially meant the smallest unit of memory in the past. -5 up to -9 bit bytes have all been used. There have also been computers that could address individual bits, known as bit-addressed machine, or that could only address -16 or -32-bit quantities, known as word-addressed machine. The term octet refers to 8-bit quantity. It is mostly used in computer networking, where computers with different byte widths might have to communicate.
Binary. Suppose the number 101 is in base 2 in binary. If we analyze the table, we can say that 101 from left to right is equivalent to 401 respective. 4 plus 0 plus 1 equals 5. So 101 in binary is equal to 5 in decimal. Addition of binary numbers. To add binary numbers, let us remember the following magic table. 0 plus 0 equals 0. 1 plus 0 equals 1. 0 plus 1 equals 1. 1 plus 1 equals 10. 1 plus 1 plus 1 equals 11. Example number 1. To add the binary numbers given below, the principles remain the same. We will keep adding digit by digit starting from right to left. we can get the 101000100 by using magic table. 0 remains 0. The solution on the last part, we can see that 2 to the 7th power is equal to 128. 2 to the 5th power is equal to 32. And 2 to the 2nd power is 4. If we add 128, 32, and 4, we can get the answer, which is 164. Example number 2. If we add the binary numbers given below, we can get 1101 by using magic table. 0 remains 0. 8, 4, 1. If you add these three numbers, we can get the answer, which is 13. Subtraction of binary numbers. To subtract binary numbers, then let us use the following magic table. 1 minus 1 equals 0. 0 minus 0 equals 0. 1 minus 0 equals 1. 0 minus 1 equals 1, but carry is required. 10 minus 1 equals 1. Example number 1. If we subtract the binary numbers given below, we can get 00010 by using magic table. 16 plus 4 plus 2 plus 1 equals 23. And 16 plus 4 plus 1 equals 21. Subtract 21 from 23, we can get the answer, which is 2. Example number 2. If we subtract the binary numbers given below, we can get 001 by using magic table. 4 plus 2 equals 6, and 4 plus 1 equals 5. Subtract 5 from 6, we can get the answer, which is 1.
The short integer can represent a whole number that make less storage, while having a small range, and the other one is long integer. Long integer can represent a whole number or integer whose range is greater than or equal to the standard integer on the same number. The difference between short integers and long integers is that they are not the same as each other, because the short integer represents a whole number and the long integer is based on whether it is greater or equal.
Multiplication of binary numbers. The product of multiplying any binary number x by a single binary digit is always either 0 or x. Therefore, the multiplication of two binary numbers comes down shifting and multiplicand left appropriately for each non-zero bit in the multiplier, and then adding the shifted numbers together. Division of binary numbers. You can also perform binary division by first converting the two binary numbers, dividend and divisor, to decimal numbers. Divide them by the regular decimal long division and convert the resulting quotient back to binary form. Repetition and Hamming codes. Hamming code is a set of error correction codes that can be used to detect and correct the errors that can occur when the data is moved or stored from the sender to the receiver. It is technique developed by R.W. Hamming for error corrections. Hamming code can be applied data units of any length. It is used to detect and correct single-bit error. Hamming code structure. Recall that all bits position that are powers of 2 are marked as parity bits and other data bits are for data bits. If the receiver did not get the correct message, there must be an error in the message. We can use Hamming code to detect and correct the error.
Binary code is the simplest form of computer code or programming data. It represented entirely by a binary system of digits consisting of a string consecutive zeros and ones. Binary code is often associated with machine code in that binary set can be combined to form row code, which which is interpreted by a computer or other piece of hardware. This is the example of binary code. Binary number system is a numbering system that represents numeric values using two unique digits, which is 0 and 1. Most computing devices use binary numbering to represent electronic voltage, which consider 0 voltage input as off and 1 input as on. This is also known as the base 2 number system or the binary numbering system. Microcontrollers use binary logic in computing. Compare this to the decimal numbering system, which is composed of 10 unique digits 0 to 9. For example, a user input 345 in decimal numbering is 10 10 1 10 0 1 in binary form. A binary file is a type of computer that is used to store our binary data. It may contain any type of formatted or unformatted data encoded within binary format. It is used to directly by the computer and generally can't read by a human. Binary file is also called as binaries. Binary digit or bit is the smallest unit of information in a computer. It is used for storing information and has a value of true or false or on or off. An individual bit has a value of either 0 or 1, which is generally used to data and implement instructions of groups of bits.
Text data. Text data technopedia meaning involves combining through a text document or resource to get valuable structured information. This requires sophisticated analytical tools that process text in order to glean specific keywords or key data points from what are considered relatively raw or unstructured formats. Text data meaning is also known as meaning or text analysis. Ang text data raw ay kilala bilang text analytics at involves rin dito ang analyzing raw or unstructured text documents to extract structured information gamit ang mga sophisticated analytical tools. In text data mining, engineered system use things like taxonomies and lexical analysis to determine what parts of a text document are valuable as mine data. Statistical models are commonly useful, and system may also use heuristics or algorithmic guesswork to try to determine which part of a text are important. Other control systems include tagging and keywords analysis, where tools look for specific proper nouns or other tags and keywords to figure out what is being written about. Gumagamit ang text data mining ng mga engineered system tulad ng mga taxonomies, lexical analysis, statistical models, heuristic tagging, and keyword analysis para ma-identify ang mahalagang bahagi ng isang text gamit ang heuristic at algorithmic guesswork for control. Another unique component of text mining is often called sentiment analysis. In sentiment analysis, which is generally much more difficult than statistical analysis, analytical tools try to figure out the mood or sentiment behind the written text and other aspects of what it is addressing on a very subjective and intuitive level. With the emergence of artificial intelligence tools,
a lot of advancement has been done in sentiment analysis, such that modern text data meaning is more than just collecting quantitative reference and involves bringing high-level conceptual models to text meaning mining to figure out new and unique ways to aggregate valuable data. Sabi rito, sentiment analysis is a unique aspect of text mining, focusing on subjective sentiments and intuitive aspects. Advancements in artificial intelligence tools have made it more than just quantitative reference, incorporating high-level conceptual rules to aggregate valuable data.
Computer logic is an aspect of computer design concerning the fundamental operations and structures upon which all computer systems are built. Any arithmetic operation in a computer system can be implemented using basic logical operations such as and or. In fact, it has been proven that an entire computer system can be designed and implemented using solely the NAND operation. These logical operations have truth tables associated with them which enumerate the output signals for particular combinations of outputs. Input signals are typically named A, B, and C, whereas outputs are typically represented as F, G, X, and Y. The part of digital logic circuit which performs one of these operations is called a gate. The basic logic gates. Digital systems are said to be constructed by using logic gates. These gates are the AND or NAND, NOR, XOR, and XNOR gates. The basic operations are described below with the aid of truth tables. Number 1. AND gate, AB and AB. The AND gate in an electronic circuit that gives a high output only if all its inputs are high. That is used to show the AND operations, i.e. AB. Bear in mind that this dot is sometimes omitted, i.e. AB. Number 2. OR gate. The OR gate is an electronic circuit that gives a high output. One or more of its inputs are high. A plus is used to show the OR operation, AB or A plus B.
Encoding and decoding. Encoding or Techopedia as an element of communication is the process of assembling the message or information, ideas, and thoughts into a representative design with the objective of ensuring that the receiver can comprehend it, while decoding is listening and reading the directions carefully. In computer application, encoding is the process of converting the characters to integers, and decoding converts integers back to characters. Error and error correction. Error correction is the process of detecting errors in transmitted messages and reconstructing the original error-free data. Error correction ensures that the corrected and error-free messages are obtained at the receiver's side. Systems capable of requesting the retransmission of bad messages in response to error detection include an automatic request for retransmission or automatic repeat request (ARQ) processing. In their communication software package, they use acknowledgement, negative acknowledge message, and timeouts to achieve better data transmission.
Even parity bit. In the case of even parity, for a given set of bits, the number of ones are counted. If that count is odd, the parity bit value is set to 1, making the total count of occurrences of ones an even number. If the total number of ones in a given set of bits is already even, the parity bit's value is 0. Odd parity bit. In the case of even parity, for a given set of bits, the number of ones are counted. If that count is even, the parity bit value is set to 1, making the total count of occurrences of ones an odd number. If the total number of ones in a given set of bits is already odd, the parity bit's value is 0. Repetition code is another mechanism that relates to error detection. It is a coding schema that repeats bits across channels to achieve error-free communication. Data bits in a stream of data are divided into blocks of bits. Every block is transmitted a predetermined number of times. They are not as effective as parity, because the occurrence of errors in the same place leads to more problems. However, they are simple and used in the transmission of number stations. Checksum is an error detection method that is a modular arithmetic sum of message code words of fixed word length. Checksum schemes involves longitudinal redundancy checks, parity bits, and check digits.